Now, let's move to the practical section and how can we get the molecules prepared or synthesized. First of all, we need to get all the glassware cleaned because any contaminants could affect the result. Therefore, we will be ending up with nothing. All right, so be cautious. The first thing you should do is to use a 100 ml of a round bottom flask with one neck. All right, this is the first step. And then you will be adding 6 ml of butanol, which is one of the alcohol, and get it stirring. This is number one. I'll show you how this step is done. While it is stirring, so just use like a stirrer, magnetic stirrer, and leave it stir. Do not stop it while you're adding the iodine to it. So while it's stirring, add 8.5 grams of iodine, okay? The iodine dissolves very quickly in the alcohol. Why? I want you to answer this question and send me the answer. I'll like set up like a time for the answer of this question. We have one more question, I think, in the next slide. And what we get out of this step is a dark brown colored solution. So let me show you like a short video explaining the addition or how this addition is done. We have done this in the lab, okay, last year, and I'll show you how this is done, okay. Now, in order to get this done, we need first of all to add some of the ethanol in the round bottom flask and keep it stirring, and add some iodine to it, okay. And you see like it's quickly dissolved, the iodine in the solution, okay. And do not add all the amount of iodine, like all of them as a one batch, because it will clog and it will accumulate and you will not be able even to like dissolve it. So that's what we are talking about. All right, now let's move to the next step. After you get everything dissolved, so you do a reflex. So what is a reflex and why we are doing reflex? So doing reflex, it's one of the steps that we do in most organic synthesis, because sometimes some reaction needs like some heat. All right, and if we heat up our like mixture, it could be like a solvent that's volatile, and it could be like a even like water. So with water, if you heat up like to the boiling point of water, it will evaporate. Therefore, you will end up with only like your compounds without any like solvent, and the reaction stops. So we gotta be careful with this point and do a reflex. So the reason of doing a reflex is to get the reaction done and without losing our solvent. So we do a reflex cautiously. It's really important because it will be like the reaction is exothermic, and it will be like evolving some heat, and it could be like any like splashing. So you got to be careful with this step. I'll show you the apparatus of the reflex. This is how it looks like. So we do have like a round bottom flask right here, okay, and we have like a heater, and we get it set up like to the boiling point of the solvent, not too much. It could be like around 60 to 65 Celsius, and we have like a condenser right here, and we have water in and water out to cool down the condenser. So let me like show you or explain to you how the apparatus or how the condenser works. So when you get like your stuff like heated, okay, and there will be like some vapors that is resulting of the heating of your mixture, it will go up to the condenser. So it's really hot. So hot vapor, okay, and you have cold water in there around it. So when it gets up, the heat, the vapor, the hot vapor, it will condense and and gets back to the flask. So it's kind of like a circle, okay? Evaporation, condensation, and gets back to the flask. And like by doing this step, we are saving our solution from getting it out. Next step is, while it's reflexing, unplug the condenser and add 0.9 grams of aluminum foil. Why? I want you to answer this with the previous question. Why we are adding aluminum foil and we don't add all the 0.9 grams of aluminum foil at a time? I mean, we need to do it like as 3 portions. So we add one portion, it could be 0.3 grams, and after 10 minutes we add the second one, and after 10 minutes we add the third one. Make the aluminum foil as 3 balls, okay, and do the addition ones at a time as we mentioned. Number 4, the condenser will get dirty and then it will get cleaned while once it begins condensing. So it's obvious that when you like heat up stuff that's like colored, it will get the your flask dirty because of that. So when it gets reflex, your solution or your solvent will go to the flask and it gets condensed, and after that gets back to the flask. So that's the main point of it. Leave it stirring for 30 minutes, which is the time that the reaction should be done, okay? And then after that, we will be adding 10 ml of cold water. This is also a question. Why we are adding water to the whole mixture? Answer it with the 2 questions before. Brown solution indicates that there is an amount of unreacted iodine. So as we always say, that when you do a reaction and you get like maybe 10% yield or 20% yield or 80% yield, that does not like mean that you got all the products. Sometimes some of the reactants did not react, and that's why we want to like discharge them and get them away from our final product. So we have here some unreacted iodine. So how we can get them out of our like products? So I'll tell you how. So in order to separate that, iodine can be reduced by adding some grams of sodium bisulfate. So sodium bisulfate is a drying agent. So sometimes we add as a powder or as a solution. So we add 2 grams of it, and the yellow free color of iodine is gone. This is an indication that we got rid of the iodine, the remaining or the unreacted iodine, okay? And then the mixture is still brown, okay, color. There is a precipitate, either an organic salt or aluminum salt. The aluminum salt, it got from the aluminum foil that we just added previously. So dilute H2SO4 must be added to 10 ml of the concentrated H2SO4 is diluted to the 100 ml of distilled water. So this is the way how to dilute sulfuric acid. So we should obtain 2 layers, dark brown layer, which is the organic layer, and dark yellow organic aqueous layer. So after that step, we need to separate these 2 layers using a separatory phenol, okay, and save the aqueous layer. We need the aqueous layer, do not get rid of it. So we then the step 8, we add sodium bisulfate solution. This is different than the previous one, 1 gram dissolved in 20 ml of water. So in order to see if there's any iodine amount to present in the solution. So the purpose of adding sodium bisulfate solution or as a powder, in order to ensure that there's no amount of iodine present in the solution. Afterward, we are separating the layers. and collect the dark brown layer. This is the layer that we are interested in, our final compound, which is the N-butyl iodide. Um, as we mentioned previously, that the synthesized iodine or compound is impure. We are not interested in purifying it for now, but we can do a purification process if we would like. Now, let me show you. This is like our final product. This is how it looks like. And the organic layer or the N-butyl layer that we want and we should collect after that is this. You can see here on the bottom, there are like two layers. This is the separation between these two layers. And this is the aqueous layer and the organic layers. Okay. We are interested only in this one. So we are going to collect only the organic layer, right? If you want to do an identification or identification of this compound, we can use the H1 or C13 NMR, nucleic magnetic resonance spectroscopy. This is a spectroscopy for organic compounds identification. I'm not going to explain it to you how it is done because it's kind of complicated and it's not like something that you should know like by this stage. So it's easy. You just like calculate the hydrogen or the proton of like how many protons do you have in your molecules, and then from that you get like some signals right here, and each one represents like compound number 1, 2, 3, and etc. And for the iodine as well. Well, here's the general equation of the reaction. So we start off with the butanol, okay, and we did mix it with iodine, okay, and after that we added some aluminum foil as a source of aluminum and some cold water, and we use sodium bisulfate as a drying agent and dilute H2SO4 to get rid of, the unreacted stuff, okay. And after that we obtained anbutyl iodide as it's shown as a 2D structure right here, and water. For the calculation, so from this synthesis you need to calculate the percent yield. So if you want to make any compound, you have to have a percent yield eventually, because let's say that you bought stuff, chemicals, and you want to do a reaction, and those chemicals cost you like about let's say $100, okay, and then you made your compound, synthesize it, and then you want to sell it, okay, and the percent yield was like very low or little. So, and let's say that it like want to sell it, okay, and you got only like $25, so it's a big loss, right? So you gotta pay attention to what you are doing, and after you get your compound done, you need to calculate the percentage yield of your stuff, okay, of your synthesized compound. First of all, we need to know the limiting reagent or reactants. I don't want you to like calculate it because it's really it's difficult. So the limiting reagent right here or reactant is butanol, okay, and you can calculate the percentage yield by weighing out your stuff, the compound you made, okay, even though it's like impure, because we are not interested in purifying it right now. And then you have the density of the butanol, and you have the density of butyl iodide, the molecules we just made, okay. For the discussion, did not like do the experiment, and we are not going to like do it in the lab, and this is a dry lab, so I don't want you to write a lab report right now. So just keep it, understand what I've just like mentioned, and I'll send you the lecture, okay. And I want you just like to answer the questions that I just mentioned. We had 3 questions, and I'll tell you the time or the date of sending me the answers of those questions. Till that time, hope you enjoy your weekend and see you then.